Hello and welcome to this session on web services. Today we are going to learn what a web service is, what is the basic concept behind web services, and why do we use it. So let us begin and let us see what a web service is. So we can say web service is a service available over the web. Now this is a very straightforward expansion of the word web service, but what does it actually means? So let us see. Let us say that we go to a hotel or a restaurant. So let us say this is you and you have gone to a hotel for having your dinner. Okay, so this is you, and let us say this is the kitchen from where the food will be served. So this is the kitchen. Okay, now what we are going to have is we are going to communicate our order to the kitchen, and the kitchen is going to serve our order. Okay, now there is a person who is involved in this communication process. The person takes your order from your table, goes to the kitchen, places the order, and then takes your food from the kitchen once it is prepared, and you get your food through the same person. And who is that person? So that person is a waiter, right? So let us say this is our waiter who is doing all this communication between you and the kitchen. So this is our waiter. Okay, so his responsibility is he has to take your order, go to the kitchen, then make sure the kitchen prepares the order and serve you back. Now here our waiter is performing the role of a web service API, or we can also say web service. He is communicating between two applications and making sure that the communication is proper and successful. Okay, now you might have a question that what is the criticality of the presence of this particular person in this communication process? Even if this person or waiter is not present, you can still go and place your order to the kitchen and then take it from there and have your food. Okay, now think about a scenario. You speak English and the chef who is present inside the kitchen speaks German, and you do not understand each other. In that case, here is a person who makes sure that you two applications can communicate with each other, and whatever uh, response you have to get from the server, or whatever request a server has to get from a client, is in a format where two entities can understand each other and communicate. So here you are a client and kitchen is a server, and you are communicating with each other. So therefore the presence of this waiter or web services becomes very important. Let us see a practical example. Let me go to a website like makemytrip.com and let us try to book a flight. So I'm booking a flight from, let's say, India, New Delhi to Mumbai. Okay, and let me just click search flights. So see what this website is doing. It is searching for all the flights between New Delhi to Mumbai on some particular date, and within few seconds it has given me all the options. So all the airlines, Air India, Jet Airways, Go Air, Vistara, and all other airlines, all the information about their flights have been listed out within few seconds. So what has actually happened here? Let us try to understand this, what has happened here. So let us say this is the website Make My Trip. Okay, and this is Air India, this is Go Air, this is Indigo, then we have Jet Airways, and others like uh, Vistara and so on. So what Make My Trip website has done in our example, it has communicated between these websites, right? So whether it is Go Air, whether it is Indigo, it has sent some request, received back a response, and then displayed the details of all the flights of all these websites. Okay, so this is what has just happened in our practical example. Now, what do you think? How is it possible for a website like Make My Trip to query the databases of all these websites, all these applications real time, and provide us information of all the flights within a few seconds? Well, one of the ways is this particular website, Make My Trip, or this particular application has access to the databases of all these websites, of all these airlines. But that might not be the case here, because no airline's website or airlines will allow a third party to go inside their database for some obvious reasons, and for some security reasons it will not allow. So that might not be the case. Okay, uh, there can be a second possibility that these airlines are dumping all the data or all the information about their flights to Make My Trip every hour or every half an hour. Okay, that can be practically possible, but think about the situation. The status of the flights can get changed every second. Okay, in that case we need real-time data. What if somebody tries to book a flight, but that flight got cancelled 5 minutes ago, but Make My Trip will show that that is available, and then there will be a lot of chaos, right? So that cannot be the case either. Now what happens here is, all these airlines have exposed their web services through an API, and this website makemytrip.com uses those web services to communicate between the airlines. Okay, so it has a common format in which it sends out a request and receives back the response in the same format, and that response is shown on their website here. Okay, so this is how they are communicating, and this is how they are making use of web services. Okay, so now you can appreciate the use of web services. Let me also put this down here. So web services is a service available over the web. It enables communication between application over the web, and it provides a standard protocol or format for communication. And this standard protocol and format, we will look into details in our coming sessions. Okay, and we have already seen the basic concept behind the web services. We will go more details into the architecture, but we know what exactly a web service has to do, right? Okay, so why we use it? Because it provides a platform independent communication. So you can have an application written in C++ over a Windows platform, and then there can be another application written in Java over a Linux platform. These two applications can talk to each other using web services. Okay, so that is why using web services we can enable communication between two different applications, and that is why we use web services. So in the coming sessions we will go into more details about web services, and we will also look at what are the different types of web services. Thanks for watching. Hello and welcome to this session on web services. Today we are going to look into an overview of how web services work. So in our last session, we have seen what web services are, and we have seen a real life and a practical example to understand web services. Now let us take a step back and let us go a little more deeper and understand the working of web services. So web services enable two applications to communicate with each other. So these applications can be entirely different. There can be an application which is written in Java over a Linux platform and it uses a Oracle database. And then there can be another application which is written in C++ over a Windows platform and it uses MySQL Server database. These two applications can communicate to each other over the internet with the help of web services. So web services are the services which is available over the web, but if that is true, then there should be somebody who is creating these services. And yes, there has to be someone, and we call this as a service provider. So the service provider or the server in the web services terminology is a entity that develops and implements the web services and makes it available over the internet or the web. And if there has to be a service provider, there has to be a consumer of the web services as well. So in web services terminology, we call it as a client. So the client sends a request to the server and the server or the service provider processes this request and gives back the response. So this is on a very high level how the communication happens, but to enable this communication we need two things. One is the medium and another one is the format. So you can think about it as when you are talking over the phone is the medium and format is the common language that the two people can understand. So in that case, in this case it can be English, right? So in the same way, in case of web services, we need a medium over which the communication will happen, and in web services the medium is the internet, or to be more precise it is the HTTP protocol that the web services use to communicate. And then there has to be a common format that both of the applications can understand. So the common format is XML or JSON, and there can be others as well, and we will look into it. So this is how the web services interact and work with each other. Now there are two types of web services, or I should say the web services are implemented into in two types, which are the major types of web services. First one is SOAP. SOAP is an acronym for Simple Object Access Protocol, and the medium that SOAP web services uses is HTTP, and to be more precise, it is HTTP post method. So in case of SOAP, whatever information you send, whether it is a request for creating something or deleting something or getting some information, it is always sent as an HTTP post, and you have to send a request in an XML format. So XML is the common format for accessing SOAP web services. The second major implementation of web services is done in REST, and REST is an acronym for representational state transfer. Here the medium again is HTTP, but unlike SOAP, in REST we can leverage all the conventional method of HTTP. So it can use post, get, put, delete and so on. Again, the format that REST uses can be XML, JSON, text and others as well. So you can see REST is more flexible and less rigid than SOAP, and in the coming sessions we will look deeper into these two types of web services and we will understand the basic architecture behind SOAP and REST. So I hope web services, how they work and how the communication happens with the help of web services is clear. So let me rephrase. Web services are service available over the web, and there has to be a service provider and then there has to be a service consumer, and they interact with each other. And to enable this interaction, there are two major things which are required. One is medium and other one is the format. So this is how web services work on a very high level. In the coming sessions we will go a little more deeper into the working of web services. Thanks for watching.
Hello and welcome to this session on web services.
Today we are going to learn two very basic and very important concepts of web services, WSDL and UDDI. So let us begin. In our earlier session, we have already seen what a web service is and how does a service provider and a service consumer talk to each other using web services. So let us see, where does WSDL and UDDI fit into the architecture of web services. So if you are a service consumer and you want to use a web service, you need to know all the details about the web service. What the web service is, what are the various components, what are the various functionalities, what are the parameters, the return types, and how exactly to consume the web service. So you need to know everything about the web service, the structure of the web services, and the entire description. To enable this, every service provider publishes a description about his web service, and this is kind of an interface to the web service where all the attributes and functionalities of the web service is described. And this is an XML based interface, and this is called, you must have guessed by now, WSDL, or Web Services Description Language. So Web Services Description Language, or WSDL, is an XML-based interface for the web services which describes all the attributes and functionality of the web service. And why is it XML based? So that it is machine readable and we can use some tools and some programming language to pass this document and generate the request and response structure. So in case you have to see an example online, you can go and we can say online WSDL and we will get some options. We can go to this particular weather web services. So this weather web service have this WSDL and we can call it through this URL, and you can see this is an XML format and it has all the functionalities and description about the web services. What are the requests, what is the components and parameter of the request, the data type, what is the component and parameters of the response, the structure, everything. Now it might be a little difficult to read and get everything about the web services through this XML document, and therefore we have tools which can pass this XML and generate all the stubs or all the requests from this WSDL document for the web service. And in the coming session we will see how exactly we do that. So we can now say WSDL is a interface for the web service, and the service provider creates this interface for his web service, and the service consumer can get this WSDL and then use the web services and all the requests of the web services. Now there are two ways a service consumer can get hold of this WSDL document. One way is, if the service consumer and the service provider already know each other, the service provider can hand over directly this WSDL document or the WSDL URL to the client, and the client can then use the web service. Now, the other case, when the service consumer and the service provider does not know each other, how can a service consumer get hold of a WSDL document? So to enable this, all the web services provider publishes the description of their web services through a WSDL to an online registry or a directory which can be searched by any consumer and they can get hold of their WSDL. And this online directory or registry is called UDDI. So UDDI stands for Universal Description, Discovery and Integration, and it is a online directory where a service provider can publish his WSDL and a consumer can query it and get hold of the WSDL. So you can now understand this like this. UDDI is a directory where all the service provider will put their WSDL document so that the consumers can query and get hold of the WSDL, and once the consumer has the WSDL, they can make use of the web services. So this is all about WSDL and UDDI in a very basic manner. I hope the concept is clear for you. We will meet again in next session and we will go deeper into these concepts. Thanks for watching. Hello and welcome to this session on web services.
Today we are going to learn what SOAP web services are and what are the rules or guidelines that make a web service as a SOAP web service. So let us begin and let us see what SOAP web services are. So any web service that follows some guidelines which are laid down by SOAP web services specifications is called a SOAP web service. So there are some set of rules, and if any web service comply and follow those rules, we can say that web service is a SOAP web service. But what are these rules or standards, and who actually defines these rules? So let us answer the second question: who defines and dictates these standards? So there is an international body that develops open standards for World Wide Web, and it is called as W3C, or World Wide Web Consortium. And this is the body that defines these standards or rules. So now we know there is a central body that lays down these rules. Now the basic and the important question: what are these rules and guidelines? So SOAP Web Service Specifications, which is laid down by W3C, has two categories of specifications. One is the basic set, and it includes SOAP, WSDL, and UDDI. So any web service that follows these three specifications can be called as a SOAP web service. And we have already seen about WSDL, which is Web Services Description Language, and UDDI in our last session. So in case you have not seen that session, you can go back and see that session first and then come to this particular tutorial. And then there is SOAP, which we will look into this session more deeply. There are some extended set of guidelines as well, and they include security and other things. And whenever we create web services for enterprise, we follow these guidelines as well. But in this session, we will focus on the basic specifications. So we have already learned that any web services that follows the SOAP web services specifications can be called as a SOAP web service, and these guidelines are laid down by a central body, W3C. And there are three basic rules that a SOAP web service has to comply to actually become a SOAP web service. So let us see what SOAP means. So SOAP is a protocol, and it stands for Simple Object Access Protocol. Now this is the expansion which was used until SOAP version 1.1, but with SOAP 1.2 this expansion has been discontinued, but we are still stuck with the acronym. So it basically is a set of rules and definitions on how two applications will talk to each other over the internet. So let us understand this. We know the client server concepts, and we know that there has to be a service provider and a service consumer, and they talk to each other with the help of web services. Now SOAP protocol says that all the exchange of data or message or information between these two applications has to be in a format, and that format has to be a common format, and in case of SOAP it has to be XML. So all the information and message exchange has to occur over a common format, and the common format that SOAP uses is XML. And it also says that it cannot be a very simple XML document. The XML message has to be a SOAP message. And what we mean by SOAP message is the message should consist of some particular structure, and the structure is made up of an envelope, a header, and a body. So let us look into this, what exactly this SOAP message consists of. So the SOAP message consists of an envelope, which is the root element, and inside envelope we can have a header. Header is optional, and it gives us information about the complex types, and it can have authentication parameters as well. And then we have a body. So let us see, envelope is the very basic root element of a SOAP message, and it contains other elements like header and body. And header is the element that provides information about the message. So the actual request is not inside the header, but header can include authentication and complex types and other similar information about the SOAP message. And then we have body, which contains our actual request. So all the parameters that you want to send as a request will be inside the body. So let us look at this example of a SOAP message. You can see there is the envelope, which is the root element, and we do not have a header because header is optional. But if you want to give some username, password, and some complex type information, that will go inside header. And then we have a body which has the actual parameters of the request, like first name, last name, and so on. So this is what a SOAP message looks like, and uh, any SOAP web services will comply to these standards of SOAP message. So now let us summarize. We have learned what SOAP web services are. SOAP web services are web services that comply SOAP web services specifications, and these specifications are some guidelines which are laid by a central body, which is W3C, and the basic set of specification include SOAP, WSDL, and UDDI. And SOAP is a protocol which defines how two applications will talk to each other, and it says that for two applications to talk to each other, they have to follow a common format, and that common format has to be XML. And the XML has to follow a SOAP message standard, and the SOAP message standard consists of envelope, header, and body. So this is all about SOAP web services. I hope this concept is fairly clear now. In the next session, we will go deeply and look into some more concepts of web services. Thanks for watching.
Hello and welcome to this session on REST web services. Today we are going to learn about REST and RESTful web services. We will go very basic step by step, and we will learn how can we call a web service as a RESTful web service. Let us begin. So REST is a very important but often misunderstood concept in web services. So let us decode REST today. In the earlier sessions, we have seen that web services can be implemented in two major ways. One of the ways of implementing web services is SOAP. SOAP used to stand for Simple Object Access Protocol. However, the expansion is now discontinued, but we still use the acronym SOAP. One of the other major ways of implementing web services is REST, Representational State Transfer. So we have already learned that web services allow communication between two applications, and one of these applications is a service provider, and then we have a service consumer. So let us learn how exactly REST fits into this architecture. So if we have to define REST, we can say that a web service that communicates between two applications using the principles of REST architecture is a RESTful web service. Now this is a very broad definition, and it is a little difficult to interpret and understand it. So let us break it down, and let us first see what is REST actually, and what are the principles that a web service should follow so that it can be called as a RESTful web service. Let us see what is REST. So REST is an acronym for representational state transfer, and it is an architectural style. So unlike SOAP, REST is not a protocol. There are no strict specifications. There is no central body which is controlling these specifications. So REST is a design principle, and you can use these principles or design methods to create any service. And when you apply these principles while creating a web service, we get RESTful web service. Now let us go a little more deeper. What exactly are these principles of REST architecture that a web service should follow so that it can become a RESTful web service? So these are some of the constraints or principles of REST. We will look at these one by one, and we will go very basics and understand what all these principles are. We will understand uniform interface, and we will look at what is a resource, what is a URI, and how exactly we use HTTP methods in REST. What is statelessness? We will understand the concept of caching, layering, and code on demand. Let us begin with the very first concept of resource.
So in terms of REST, everything is a resource. Let me take an example. I'm trying to create an application for employee management system. Now I can create this application with any language on any platform, and I can use any database for the backend. So irrespective of the language or the platform or the database, I will have some modules and entities in my application. There will be a module for employees, and employees can have attributes like ID, name, and addresses. They can be a module for departments, and departments can again have ID, names, etc. And there will be some other modules. Now, in REST, the concept of resources says you can define any information or any module as a resource. So if I want to have the resources for my application, I can define a resource for employees. I can define a resource as departments, and every module I can define as a resource. So I can name my resources and I can define them for my application. Now, REST does not say that there are some strict guidelines that what exactly you should define as a resource, and it says that you can define any information or any data or any module that you want as a resource, and you can give a name, right? The second concept of URI says that you can access any data or any module with the help of a uniform resource identifier. So for example, if I create this application and I host it somewhere, I can use the domain name and then /employees to access the employees resource. Now if I want to go a little deeper and access the details of a particular employee, I can say /employees/id. So if I want to get details of an employee with ID 10, I can say /employee/10, and it will access the details of the employee with ID 10. Similarly, for departments, if I want to get the details of some particular department, I can say /department/id. So in case I want to get the details of a department with ID 123, I can say /departments/123. Now this is very straightforward. In my application, I must be having some tables for employees and some tables for departments. And all these tables will have linkages to each other. They will be one to many, many to one, and many to many associations with all these tables. So at the backend, it is we can have all these interlinkages. But what if I want to get the list of all the employees from a particular department? What will be the URI? I think you might have guessed by now. It should be /departments/id of the department/employees. So in this case, I will get the details or list of all the employees under the department 123. So this is how we can make use of resources and URI in REST. And Roy Fielding, who actually coined REST, says that any information that can be named can be a resource. It can be a document, an image, and so on. So there are no strict guidelines that what are the entities or modules that are there in your application should be considered as a resource. You can name anything and you can have any resource as your wish. So this is what the concept of resources are. Let us go forward and let us see how does we make use of HTTP in REST. So we know HTTP has some methods. We have get, post, put, delete, headers, options, and so on. And we can do a create using post, we can do a read using get, we can modify using put, and we can remove using delete. Now in REST, we make explicit use of these inbuilt HTTP actions. So for example, if I want to retrieve the details or the list of all the employees, I will do a get on the URI/employees, and it will list out all the employees from the system. Similarly, if I want to access the details of a particular employee, I will do get on /employees/10. In this case, I will get details of the employee with ID 10. So I hope you are understanding this. We can use the HTTP methods along with the URI, and we can access any resource or modify or create a resource. So for example, we can do a get we can do a delete, we can do a post. In case of post, we also have to uh, give the data of the new employee, so that in the response we will get the ID of the newly created employee. We can do a put, and again we have to pass that data that has to be modified, and in the response we will get a success message if everything goes fine, and so on. So this is how we can use HTTP methods with URI, and we can access and modify any resource. Also, if you have observed, resources are proper names and HTTP actions are verbs. Now if you notice, HTTP actions are verbs here and resources are proper names, and we call it as nouns. Now there are no strict guidelines that says that you always have to name your resource as proper names, but it is a good practice in REST that whenever you are naming your resources, you keep them as proper names, and HTTP actions will be verbs, so that you will not find something like get employees or create user in REST, but we only have a resource called employees, and we can do a get on it, we can do a post, delete, or update on it. So I hope the very first concept of uniform interface is very clear, and we have learned about resources, URI, and HTTP, and how can we access or modify a resource using the URI and HTTP methods. Uniform interface also says that we can do manipulation of the resources using representations. Now we will look into representations into more detail, but for now we can understand that every resource can have a representation. It can be represented as an XML, as a JSON, as an HTML, and so on. And we can modify this representation or manipulate as per our needs. The other thing is, the first principle uniform interface also says that the messages that gets transmitted are self-descriptive. That means that it does not only contain the actual data, but it also contains some more information. For example, if a response has to be cached or not, for example, if the request has to be authenticated or not, all this information will be there in the message itself. So I hope this concept is clear, and let us also see the differences with SOAP. So suppose I want to retrieve the details of an employee with employee ID 123. This is how my request will look like in SOAP. I will have to follow all the guidelines of SOAP specifications. There will be a SOAP message with a particular structure having envelope, header, and body, and this is how the request will look like. The same thing if I have to do in REST, it will be a simple URL with /employee /123, and when I do a get on this, I can retrieve the details of the employee with ID 123. So now you can appreciate how easy, flexible, and lightweight REST can be. Let us take an example. Let us go online and let us go to this particular REST request, and you can see it has given me a list of resources. We have customers, invoice, items, products. So in case I want to go to the customer resource, I will just say customer in the URL, and I will just hit enter, and you can see it has given me the details or the list of all the customers. If I want to go to this particular customer 10, again I will just go to the URL, say /customer /10, and I am now getting the details of the customer with ID 10. So you can now see how easy and flexible REST can be. So we now know what uniform interface is, what are resources, what are URI, and how do we make explicit use of HTTP methods. In the next session, we will go and look into the remaining principles of REST. What is statelessness? How do we do caching, layering, and code on demand? Thanks for watching. Hello and welcome to this session on REST Web Services. Today we are going to learn some of the principles of REST Web Services. This session is going to be a continuation from our last session where we looked at REST and we understood about RESTful web services, and we started with the principles of REST. So let us begin. In our last session we have learned about uniform interface, and we looked at what is a resource, what is a URI, and how do we make use of HTTP methods. Today we will look at statelessness, what is caching, what is layering, and what is code on demand. So let us begin with statelessness. And in a RESTful architecture, we say that all the request and response or all the communication between client and server are stateless. And this means that the server does not maintain any state of the system, and the client has to send a request which is complete in itself. So the client sends a request which is independent and does not depend on any of the previous request. Let us understand this. So statelessness says that server should not require to store the state of the session, and it means that the client has to send a request which is complete and independent and a complete entity in itself. Let us take an example. If you are doing an online shopping and you are adding items to your cart, now the server will not maintain the state of your cart. So every time you are sending a request to the server, it should also include the current state of your cart. And how does this happen? We will look into the next concept, which is caching. So for statelessness, because the server does not have the overhead of storing or maintaining the session, therefore it improves the web services performance. Now let us go to caching. In the last concept, we saw that the server does not maintain the state of the session. So in that case, how do uh, the two entities, the client and the server, communicate when we have to coordinate with each other? And for example, there is a login scenario where the server has to know whether the authentication is successful or not, and similar scenarios. So that happens with caching, and caching happens at the client side. So whenever a client sends a request to the server gives back the response which contains the actual data, and along with the actual data there are some other metadata or there are some other information in the headers which tells the client whether it has to store the response locally or not, or in other words whether the client has to cache the response or not. So the server generates a response, and in the response we also have some headers like cache control and last modified, which tells the client whether the response should be cached or not. Let us see an example of a response. So this is a response from the server, and if we look at the headers, we can see that there is a cache control header which tells that what is the maximum time that this response should be cached, and then you can also see an e tag here, right? So e tag is entity tag, and uh, every unique version of the resource has a unique entity tag. So if the resource changes, there will be a new entity tag given to that particular representation. So with this, we can do caching. So the client uses the cache control header to determine whether the resource or the response has to be cached or not. So with this principle, it helps coordinate between client and server and maintain a coordinated communication, and this is how the server can remain stateless. So this was the concept of caching. Let us understand layering. Now, when there is this communication between client and the server, REST principle says that there can be multiple layers in between, and these layers can be HTTP intermediaries, and they can be used for a number of purposes. They can be used for message translation, improving performance, caching, etc. So we can also have layers like proxies and gateways. So proxies we can have for evaluating the request or simplifying the request, and gateways we can have for managing the traffic at the server end, and so on. We can also have some layers which can help us in caching. So for example, we have a layer which helps in caching and stores the response for an hour. And if we get a request from the client within that hour and there is no change in the resource, then we can get the response back from this particular layer and there is no need to go to the server. So it improves performance and scalability. So layering improves the scalability, and now we can understand exactly how layering works and what is the concept of layering. The next concept is code on demand, and it is an optional constraint of REST web services. So it is something like when you send a request, you get back a response. The response has the ability to run some code or some JavaScript on the client side. So again, it extends the functionality of the client. So this is an optional constraint of REST. I hope now we can understand what is representational state transfer means. So this means that every resource can be represented in multiple ways. So a resource may have a representation in an XML format or a JSON format, and whenever there is a request from the client, the representation of the current state of the resource is being transferred between client and the server. Let us look at an example. Suppose I do a get on the images resource and I want to retrieve the image 1, and the representation I am requesting is JPG. So I will get a response with the JPG representation of the resource. Now if I again do a request and I do a get on the images resource and I want to get the details of image 1, but this time I want a representation in XML, I will get a response with the XML representation of the resource. So now we can understand representation is the description of the current state of the resource, and we can have multiple representations. We can have XML, we can have JSON, we can have HTML, YAML, and many other representations of our resources. So I hope all these principles are very clear now. So let us go back and let us summarize. We know REST is representational state transfer, and it is an architectural style. It is not a protocol and it is not a specification which is given by some central body. It is very flexible and lightweight. And when we use these design principles to design a web service, we get RESTful web service. And it is a set of rules, and it guides how a data or information should be exchanged between two applications. So REST was a term which was coined by Roy Fielding in the year 2000, and in his doctoral thesis he introduced the concept of REST. So I hope we are now very clear with REST and RESTful web services, and we have decoded all the basic concepts. I will meet you in the next session. Thanks for watching.